When you look at the world's dry landscapes, two broad climate types often come up: desert and steppe. At first glance, both seem like places defined by dry air, limited rainfall, and hardy plants, but there are subtle differences. Both desert and steppe climates fall under what geographers call dry or arid or semi-arid climates. In other words, whatever moisture reaches the ground is quickly whisked away again. But not all dry climates are created equal, and that's where we begin to see differences between desert and steppe. The biggest and most straightforward difference between desert and steppe climates is the amount of rain they receive. Deserts are the driest of the dry. Steppe climates, on the other hand, are a bit more forgiving. They still don't get a lot of rain, but they usually receive more annually than deserts. It's modest, to be sure, but it's enough to support more vegetation than the stark emptiness that we often associate with deserts. Now, deserts are often pictured as endless seas of sand. And while not all deserts look like the Sahara, you have some that are rocky, others that are covered in hardy shrubs. One thing that they tend to have in common is extremely sparse plant life. The plants that do survive in desert climates, like cacti and certain shrubs, are masters of water conservation, storing moisture or having tiny leaves that reduce water loss. In a steppe environment, that extra bit of moisture changes everything. The landscapes are usually covered in grasses and low shrubs. Trees are still rare, but the continuous cover of short grasses gives steppe regions a distinctive, rolling, grassy appearance. This difference in vegetation not only creates a more hospitable home for grazing animals, but also influences how people have historically used steppe regions for farming and herding. Both deserts and steppes can have hot summers and large daily temperature swings. Deserts, with their lack of plant cover and moisture, often experience more extreme temperature changes from day to night. Without plants or soil moisture to hold onto the day's heat, the temperature can plummet after sunset. Steppes, while also prone to temperature swings, are somewhat moderated by their grasses. The vegetation helps slow down temperature changes, making the climate slightly more even, though still on the dry side. Deserts and steppes often appear in similar parts of the world, regions that are rain shadows behind large mountain ranges, or areas far from oceans and moist air currents. Deserts typically occupy the driest core areas, while steppe forms a kind of transitional zone circling those deserts. You might see a true desert at the very center of a large continent where moisture rarely arrives, while the surrounding edges, still dry but not quite as harsh, become steppe lands. So let's take a more detailed look at steppe as a climate type, and we'll be using the Köppen climate classification system here. Under the Köppen climate classification system, steppe climates are under the designations BSK, which is a cold semi-arid climate, and BSH, which is a hot semi-arid climate. The B climate group, the letter B in the system, represents arid and semi-arid climates. Steppe climates, therefore, share certain traits with deserts, like we discussed. Deserts are BW climates, but they're differentiated by slightly higher precipitation and milder dryness indicators. The S designation in BSK and BSH for the cold semi-arid and hot semi-arid climates indicates those semi-arid or steppe conditions, lying between the true desert conditions and more humid climates. And then you have the thermal distinctions, either H or K, those last letters of the climate designation. H stands for hot and K for cold, and that further categorizes down steppe climates by temperature. BSH climates, or hot climates, exhibit higher average annual temperatures and are typically found in subtropical latitudes, while BSK climates occur in cooler mid-latitude regions. Steppe climates receive enough precipitation to support continuous grass cover rather than that sparse desert vegetation like we discussed. They're neither lush and humid nor barren and hyper-arid, so they're like a transitional environment. When you think of the precipitation range for semi-arid climates, Think about a range that's too dry for forests, but too wet for deserts. There's not enough moisture for sustained tree growth or for dense forest canopies, but they're not as dry as deserts, so you have that ground cover dominated by grasses and low shrubs. You also have a seasonal concentration. In many steppe climates, much of the limited rainfall arrives during a particular season, often in the form of convective thunderstorms in summer months for mid latitude steppes or mild winter rains in subtropical steppes. You have an influence of continentality and topography as a defining feature of steppe climates. They're typically far from large bodies of water. They lack maritime moisture sources, and these continental interiors foster conditions where evaporation often surpasses precipitation. You also have a very common distinguishing factor of having a rain shadow effect. Many steppe environments lie in the leeward side of mountain ranges that strip moisture from the prevailing winds, leaving only modest rainfall for the downwind plains. As we discussed, you have those seasonal temperature variations, including significant diurnal and annual swings. So you might have hot summers and cold winters. Mid latitude steppe climates often have very hot summers and frigid winters, reflecting that inland position and a lack of a moderating ocean influence. In subtropical steppe climates, you might still have hot summers but have milder winters. And then you have that diurnal range. The high pressure, clear skies, and low humidity contribute to significant temperature differences between day and night, just like you'd see in a desert climate, but less so. Daytime warmth rapidly radiates away after sunset, resulting in cooler nights even during some of the hottest months. They're also characterized just generally by seasonal patterns. So, without the buffering effect of nearby oceans, in many cases, steppe climates can have pronounced seasonal identities with harsh winters and summers that are characterized by more intense heat or some intermittent rain events. And they're also marked by that transitional nature, right? This situation between arid and more humid zones that means that even small climatic shifts can drive some noteworthy changes in the length and in the intensity of seasons. On the ecological side, steppes are again kind of ecological frontiers. They bridge deserts with their arid, sparse vegetation and the more productive grasslands or forests. They serve as those transitional zones, but they respond sensitively to changes in moisture and temperature. When you're thinking about vegetation and soil in steppe climates, unlike many deserts where vegetation can be extremely sparse or only found in certain patches near oases or ephemeral washes, steppe regions maintain a cover of drought tolerant grasses and herbaceous plants. Desert soils might remain thin, rocky, or sandy due to limited organic matter, but steppe soils are more developed. They're often richer in organic content, and this indicates a more hospitable environment for plant growth and soil building organisms. So, where do we find steppe? Well, globally, look at continental interiors. You have the Eurasian steppe. It's one of the most extensive continuous grassland ecosystems in the world, stretching through Eastern Europe, southern Russia and Ukraine, across Kazakhstan and Mongolia, and extending into parts of northern China. It's located mainly in the mid latitudes, and these grasslands occupy large areas of interior Asia, far from the moderating influence of the Atlantic, Pacific, or Indian Oceans. Due to their inland position, Eurasian steppe climates experience a pronounced continental effect. They have hotter summers and winters that go much lower. Think also of the Great Plains of North America that stretch from Canada to Texas. They span an enormous distance from the Canadian prairies, think Alberta, Saskatchewan, Manitoba, southward through the central United States, parts of the Dakotas, Nebraska, Kansas, Oklahoma, and into portions of northern Texas. These steppe environments are influenced by the rain shadow effect of the Rocky Mountains, which block moist Pacific air masses and lead to reduced precipitation on the plains. While today much of the North American steppe has been converted into farmland, producing significant portions of the world's grain crops, the fertile grassland soils once supported a dense cover of prairie grasses and an abundance of large herbivores like bison. Going farther south, you can see the Pampas and the Patagonian steppe in South America. In South America, steppe climates are found in parts of Argentina, notably the Pampas and extending into Patagonia, and to some extent in neighboring countries, though Argentina's interior grasslands and semi-arid plateaus are the most expansive examples. The Pampas, which are closer to the Atlantic and at subtropical to temperate latitudes, receive relatively more rainfall than the Patagonian steppe, which lies farther south in a cooler, more arid condition. The Pampas are a transition zone from the more humid coastal climates to interior dryness, with precipitation generally decreasing as you go westward. And farther south, the Patagonian steppe lies in the rain shadow of the Andes and results in cold, dry conditions. While the Pampas experience milder winters and warm summers, Patagonia's steppe-like areas are cooler year-round, reflecting their higher latitudes and their proximity to the Southern Ocean. Looking at these areas, you can see some common themes for continental interiors. You have that distance from oceanic influence, where they receive less maritime moisture, resulting in lower and often more erratic rainfall. You have the rain shadow effect in many areas, lying beyond significant mountain barriers, which contribute to their dryness. And you have a sensitivity to climatic shift because those grassland environments often exist on the threshold between the more humid and the more arid conditions. They're especially susceptible to changes over time. Guys, thank you again for watching. Everything I do, all of these videos, my main aim is to improve the procedural map generator. If you enjoy the videos or you want to learn more about the procedural map generator, please hit like and subscribe below. It helps with the algorithm, helps with the project. I appreciate it.